17. Lesson 17. Okay, it's been a day already. We are looking at more limits. Specifically, it's infinity as a limit and undefined limits. So I think all of our limits today involve infinity and how we can think about those. Okay, so ways to think about those. First of all, we're going to look at a table of values. So we're going to use a calculator to do this to see what happens for the following limits. So we've done this at some point. So go to your y equals and type in that first fraction there, or the first equation. So 2x divided by x minus 2. Make sure if you're not using a fraction bar, you put that denominator in parentheses.
How do you even get to the fraction bar?
I use alpha F1 as the shortcut I use. Does that make sense? Yeah, that's the shortcut I like. Now, we're not going to graph this and look at this. We're going to look at a table of values and see what happens. So this example specifically is as x approaches negative infinity, yes? So we're going to be looking at values to the left, all the way going to the left. So we're going to look at a table here in a moment, which is the second function of graph. But before we do that, let's do, well, okay, let me go ahead and go into table first of all. So second table. F5. Above graph. Sorry, I didn't mean to jump. Okay, so table is the second function of the graph button. Okay, so now I haven't done any settings on this table yet. You may have different x values showing than me, depending on how you last used this. So it is possible you have different x values showing than me. Not a big deal. Okay? So, what this is showing though, for that equation we just typed in y1, notice these are y1 values. So, for mine, it's showing when x is 0, y1 is 0. When x is 0.1, y1. It shows those values. Does this help me figure out what my limit is as we approach negative infinity? No. Negative infinity means I need to look at x values that are getting what? Smaller. So, for me, if I arrow up, I can kind of start looking here about what's happening. Okay. Now, wherever you're at, you can arrow up to where you're getting smaller, right? However, okay.
I have a y10.
I don't know.
Should I try and zoom in or going all the way down from this number that it pulled me on to, or just?
Where's that at?
Well, okay, so I'm going to change fractions are going in.
Before this, mine was just what was there when I got there.
I entered an equation in y1.
Oh, you did?
Okay, guys, back up with me here. y1. We are working on this limit problem. Did you enter this limit on this problem on y1? Okay? Now, we're all starting different points, yes? If we all want to start in the same point, let's go into table set this time. So second and the window button. We're going to set up our table. And we can choose where our table value starts. So when we go to table here, what value we'll be looking at. Right now it's kind of based on where you're at. I think I'm going to use my table start value as a 0. But I don't like that 0.1 thought. Because that 0.1, it's going to take me forever, yes? I want to know what's happening as we're going to negative infinity. So I want to know what's happening as we're getting much, much smaller, right? Okay, so we could go by hundreds. We could go by thousands. You can go by twos. You can go by anything you want. So my delta table is the increment yours is changing by. Honestly, I was going to go by thousands. So delta table, I'm going to put 1,000 in. This just indicates what it changes at. If Jackson puts 100 in his are going to be counting 0, 100, 200, 300. Mine's going to be counting 0, 1,000, 2,000, 3,000. Does that make sense? If it said 0.1, yours is counting 0.1, 0.2, 0.3, 0.4. So now, after you get however you want that, go ahead and go back into table. So second, table. How do I get that out of fraction form? Because now I have Aubrey's problem.
Go to mode. Press mode.
If I go into mode, that'll change it?
Yeah. And then answers.
Huh. Okay, I just learned something new. I didn't think about that. Do you guys see what he's doing? We're in mode. Answers, decimal. So auto means it will just kind of vary. Sometimes it'll give fractions, sometimes it'll give decimals. If you hit decimals, it's now always going to hit decimals until you turn it back. Does that make sense? I didn't know that. I haven't played with that option. So if I enter on decimals, then I go back to my table again. Hey, now I have decimals. Thanks, Jack. Okay. Now, we want to know what's happening as it approaches negative infinity. So I have it right now, my positives are showing. So can you arrow up? Okay. Look at what's happening, guys. As my numbers are getting smaller and smaller and smaller, my x values. What are my y values getting closer to? Can you say that with pretty good confidence? Okay. So you should be able to say that with pretty good confidence. That's why I picked a bigger value. However, Jackson, did you end up picking 100? No? Okay. Because it still would have still would have been able to figure it out. So, the question is, the limit as x approaches negative infinity of this fraction is what? What y value are we approaching? 2. Does it? Okay, when you get so far. Now, for work, I'm just going to show you a table of values. At 0, it was 0, 0. At negative 1,000, I have 1.996. At negative 2,000, it was 1.998. At negative 3,000, it was 1.9987. And again, this was specifically as x approaches negative infinity. Okay, let's try the second one. What's different on the second one? First of all, it's the limit as x approaches positive infinity. And then, before we do anything, we need to go back into our y equals. And when you change your y equals, so now y equals is going to be 1 divided by x. I'm going to go into my table set, so second window. Because of where I left off, as my table start value is negative 21,000. I'm going to go back and take that to 0 because I'm going to be able to start at 0. I'm going to leave the table value of 1,000. I think we'll be okay there. So now go into my table. Okay. Well, so first of all, what are all these e's? Those are essentially zeros, right? Or very close to zeros. But now, these aren't huge zeros. Because, so, 1,000 is 0.001, yes? Let's go down and look at 10,000. 10,000 is 1 times, it's e to the negative 4. So it's 1 times 10 to the negative 4. Well, what does that make it? It goes 1, 2, 3, 4. And so that makes it 0.0001. Okay, Riley said he went by hundreds and he could tell better. So 100 doesn't really work. Okay. My 100 kind of works
Why is 0 here?
because my equation was 1 divided by x, and we can't do 1 divided by 0. In other words, there's going to be an asymptote there. So it's an error because it doesn't exist at that value. But the table won't skip over that value. You'll still put it in there. Okay? So pick something that works for you. Okay? Yeah, see, eventually you get to the e's, but you have to be able to figure out, what are we going closer to? Can you see that we're going closer to 0? As x is going off to positive infinity, so as my numbers, I want positive this time, don't I? Dang it. I went the wrong way, didn't I?
50s.
Okay. So, as my x values are getting bigger, what's happening to my decimals? They're getting smaller and smaller and smaller, yes? And as they're getting smaller and smaller and smaller, they are going to approach 0. So, the answer to this limit is 0. If I give you an XY chart to kind of show you, well, when we put 1,000 in, think about it. It's 1 over 1,000. So that is 1/1000th, which is 0.001. If you put in 10,000, that's 1/10,000th, 0.0001. If we put in 100,000, that is 0.00001. Again, do you see how the table shows where we're getting closer to? Okay, so we can look at graphs. We can look at the table. We're going to look now, we're going to talk about our method so we don't have to use the graph. We don't have to use the table necessarily.
Honestly, kind of sounded like we were preaching just now. Like,
Okay.
you're telling me, like, we don't have to use a table. Like, I don't know.
I'm preaching calculus.
It was so enthusiastic.
Okay. The following happen when infinity is plugged into certain problems. Because we are looking specifically at limits that approach infinity. When we did limits a couple of days ago, we would try and get it simplified, and then we would just plug the value in, yes? Okay. Easier said than done with infinity. I mean, we can plug the idea of infinity in, and we'll talk about that some, but it's harder sometimes than others. So, first of all, if you have a constant number, or something such as 1, and you divide it by infinity. So if you take a small number, or just a set number, and you divide it by infinity, that is going to turn into 0. It is approaching 0. Notice it doesn't say it's exactly 0, but it is approximately 0, because it's getting closer and closer to 0. Flip that upside down. If you have infinity divided by a number, so if you have a number that's getting increasingly larger, and you divide it by a set number, what's happening to the result of that? It's getting increasingly larger. So infinity on bottom is going to result in a 0. Infinity on top is going to result in infinity. Infinity divided by infinity. Well, officially, what happens when you divide something by itself? It's approximately, it's 1, right? So again, this is an approximation. Let's look at example 1 here. Evaluate the limit as x approaches infinity of 4x squared plus x plus 6 over 3x squared plus 1. If we just start plugging infinity in there, can we come up with a specific answer? I mean, you've got 4 times infinity squared plus infinity plus 6. Okay? It's kind of like infinity, but we need to be a little more specific than that, too. 3 times infinity squared plus 1. Again, it's infinity, but we're thinking not quite as big. Technique here. Okay. And this works when we are approaching infinity. Okay. Is that we're going to divide each term in this problem by the highest power in the denominator. So what is the highest power in the denominator? X squared, yes? Are we okay with that? So what I'm going to do, and I'm going to show a lot of work this first time through, is I'm going to rewrite this limit. It's still the limit as x approaches infinity. But we're going to rewrite this. So we're going to take 4x squared, and we're going to divide it by x squared. Plus, we're going to take x, and we're going to divide it by x squared. Plus, we're going to take 6, and we're going to divide it by x squared. And the denominator, what am I doing? Still dividing everything by x squared. So 3x squared divided by x squared. Plus 1 divided by x squared. Once you get into this, we won't write this step out. This is kind of an annoying step to write out. But I think it's important to understand what we're doing. And drew that long line extra long. I'm going to go through and do some cleanup. So it's still the limit as x approaches infinity, yes? Let's clean up each of those pieces. What is 4x squared divided by x squared? 4. Plus, what does x over x squared simplify to be? Okay, I'm going to go with 1 over x. I agree it's x to the negative 1, but I prefer the fraction form for what I'm going to do. Okay? Are we okay with 1 over x? Basically, a set of x's cancel. Plus 6 over x squared. That's still 6 over x squared. Okay? Clean up the denominator. What do you know about 3x squared over x squared? Cleans up to be 3 plus 1 divided by x squared. 1 divided by x squared, yes? Okay. I am essentially ready to take the limit. And when we take the limit, we are essentially plugging in infinity, yes? But we'll actually be able to come up with something now. So think about plugging in infinity every place you see an x, right? So we're plugging infinity into those places. Excuse me. So my numerator, when I plug infinity in, what do you know about 4? It's going to stay 4. There's nothing to affect it. Plus. Now, we had 1 divided by x, which you are plugging in infinity. What do we know about 1 divided by infinity? 1 divided by an increasingly bigger number is going to approach 0. Plus, what about 6 divided by x squared? Well, that's 6 divided by infinity squared, which 6 divided by a really bigger number, an increasingly bigger number, approaches 0. Denominator, the 3 is going to stay 3. 1 divided by x squared approaches 0. I ran out of room for my answer. What does this problem equal? 4/3.
Wait, 4 plus 0 plus 0 over 2
4/3 was on our mouth joke.
Coincidence, but yes, it was.
Hey, question.
Yes, Riley.
How does 6 divided by x squared, like when you plug in infinity, how does it become 0?
It's because it's just like doing 1 divided by infinity when you are doing a set number. So in the big scheme of things, 6 is small. 6 is a very small number in the, in talking infinities. And so when you're doing a small number such as 6 and dividing it by an increasingly bigger number, it's going to get closer and closer to 0. Okay? And I mean, you can do, take your calculator, do 6 divided by 1,000, 6 divided by 10,000. So, and you'll notice it getting smaller and smaller. Does that make sense? Now, what did we do to do this? We divided by, I'm probably writing off the screen, aren't I? I'm just writing a note of what I did here. So when you look back at this later, you'll have some idea. We divided by the highest power in the denominator. So in this particular example, we divided by x squared. We picked x squared because it was the highest power in the denominator. Shortcut wise, did you guys catch it? When your highest powers match, what did our limit end up being? The coefficients. Because all these other little things didn't matter. It was all about the highest powers. The highest powers control it. Okay? Kind of like when horizontal asymptote, when the highest powers match. There you go. Okay. Same technique on example 2, if you would. The limit, now notice this time it's limit as x approaches negative infinity. We're going to do a similar technique though. Okay? Because right now if you plug in infinities when everything has x's, we don't really know. So what is the highest power in the denominator? Okay, notice it's specifically the highest power in the denominator. Divide everything by x squared. So it's still the limit as x approaches negative infinity. Now, do you want me to write it out like I did first step last time, or can we jump to second step, where we have the simplified versions? So, I'll talk you through it here, but think about this. X cubed divided by x squared. What is x cubed divided by x squared? X. You guys with Wade? X cubed divided by x squared is x. Plus, what is 6x divided by x squared? Not 6 over x squared, 6 over x. Because an x cancels.
Okay.
Right? Denominator. 8x squared divided by x squared. Whole number 8. Plus 5x divided by x squared. 5 over x. So this time, last time I was plugging in positive infinity. This time, in a sense, I'm plugging in negative infinity. Yes? So when you plug negative infinity into x, I'm going to write that as negative infinity. Plus, what about 6 divided by negative infinity? Still 0. I don't care if it's divided by positive infinity or negative infinity, you are still approaching 0. So on top, I have negative infinity plus 0. Denominator. 8 is 8 plus 5 divided by x. So 5 divided by negative infinity is 0. So the point is, did anything matter besides the lead terms? No. These other guys don't matter. And so now, what do you know about negative infinity divided by 8? Except it's not going to equal positive infinity, it's going to equal negative infinity. So like if you're working with negative infinity, it equals negative. If you're working with positive, it equals positive. Because if we take an increasingly smaller number, it's getting smaller and smaller and smaller, but you're still dividing by 8. When you get really small, does that 8 really matter? No. Just like when you get really big. 8 is really a relatively small number. So this answer is negative infinity. And that's kind of along the idea up at top of infinity divided by a set number is infinity. So now, kind of the connection here, larger power was on top, yes? Okay, there's kind of a connection there. Are we okay with this? You gotta tell me if you're not, and I'll explain differently, or I'll try to at least. Example 3. Again, we are approaching infinity. So, when we're approaching infinity, we're going to divide everything by what? Yx squared. Highest power in the highest power in the denominator. I'm tongue-tied today. So, write out what they are, cleaned up. What's 5x divided by x squared? 5 over x. Plus 7 divided by x squared. Okay. So, in my mind, I already see where my numerator's going. Because I've got two little fractions there. Denominator. 13x squared divided by x squared. 13. 10x divided by x squared. 10 over x. And 2 divided by x squared. You guys agree with that?
I do.
Both pieces of the numerator turned into zeros because they are set numbers divided by infinity. So my numerator is 0 plus 0, which I get it. If you guys are at that point, you're ready to just write 0. Awesome. My denominator, 13 stays 13. We have 2 zeros there. So I agree, 0 divided by 13. What is 0 divided by 13? 0. 0 divided by anything is 0. These are limits you'll like once you get the feel for them. Okay? They're easy. You just have to get that feel for them, get that routine. When you see it being x approaching infinity, you want to divide by the highest power in the denominator. Okay, how are we doing on time? On the denominator, or on the back side. Denominator? Man. Sorry, tongue-tied today. It says, now let's look at the following limits on a table of values and on a graph. I think I'm going to skip to graph if you don't mind. Graph is a little bit quicker and easier. So, if you would please, I'm going to sketch the graph on here. So, go ahead and pull up a graph for me. And by the way, if you don't always want your calculator in decimal form, don't forget to change that mode back that we changed earlier. And I'm not saying, some of you might not care, but I like when it gives me fractions sometimes. Sometimes I don't.
How come it only has a decimal and auto, but the
Mine has
a decimal, fractional, and auto?
Really?
Yeah, mine is auto.
Mine's auto or decimal? What do you have? Auto, decimal, and fraction?
That's weird. They don't have both.
Interesting. Okay. Whatever it is. Okay, 1 divided by parentheses x minus 2 parentheses squared. I'm going to do a zoom 6. What do you see happening here? There is an asymptote. Where is that asymptote at? 2. How do I know that asymptote is at 2? Never touches 2. Or remember, vertical asymptotes happen when we set the denominator equal to 0. So there is a vertical asymptote at 2. You can also tell that by looking at your graph, right? And so this graph So, what is the limit as x approaches 2 of 1 over x minus 2 quantity squared? And let me say, as we do this, it has to agree. So what happens as x approaches 2 from the left? Where's my graph going? Up to positive infinity. Has to be the same for both the left and the right. So what happens as x approaches 2 from the right? Is my graph going up both times? Yeah. Those up arrows represent positive infinity. So it agrees. So my answer to this problem is positive infinity. Okay. Let's go to example 2. This time we're going to graph 1 divided by parentheses x minus 2 parentheses. Again, if you're not using a fraction bar, put that whole denominator in parentheses. Similar graph, except what happened? Yeah, one of them's going down this time. So let me sketch my graph in my notes again. Again, does it make sense there's a vertical asymptote at 2? Yes, because that's where my denominator equals to. So now, this time, the limit is still as x approaches 2, yes? What happens on the left as x approaches 2? My graph is going down to negative infinity. What happens on the right as my graph approaches 2? It's going to positive infinity. Are negative infinity and positive infinity the same thing? So what about this limit? Okay, so 2 ways to say it. You can say undefined or limit does not exist. So I have undefined written in my notes, but you also will hear DNE, limit does not exist. So realize if you see DNE in calculus, that does not exist. Okay. You ready for the last one? So go ahead and graph the last one when you're ready. Negative 1 divided by parentheses x plus 3 quantity squared. Where's my asymptote going to be at this time? Negative 3. How does he know that? Maybe he's already graphed it, maybe he hasn't. But how do you know that without looking at the graph? Denominator equal to 0. So, this is the limit as x approaches negative 3. I know before I even look at my graph, I have a vertical asymptote at negative 3. Does this graph make sense then? It does. So like the last one, it's running along a horizontal asymptote of the x-axis. This is as x approaches negative 3. Again, left and right must agree. What's my graph doing as it approaches negative 3 from the left? It's going down to negative infinity. What's it doing as it approaches negative 3 from the right? Going down to negative infinity. So what do we know? Limit is negative infinity. So official notation would be the limit as x approaches negative 3 of negative 1 over x plus 3 squared equals negative infinity. That would be your official notation.